Hello and welcome back to Crocoduck Science, where we have a sweet logo and talk about stuff. Today we thought we would listen to our only subscriber so far. Thank you very much, Michael Sangster, and thank you to everyone else. Our 100 viewers, I think we cracked a few days ago. So 100 views is the hardest 100, I think. I hope.
Yep, first 100's the hardest.
Yeah. So thanks everyone for that, and following advice of our first subscriber, we thought we could do a few videos about particular topics, a few shorter videos. So today we chose a brief history of the universe, so just a small subject.
Yeah, not much has happened so far in the universe, so I guess we should be over and done with in a short while.
Yeah. So the general age agreed of the universe is 14 billion years, give or take. I think it's actually 13.7.
Looks to be about just under 14 from that scale there.
Right, yeah. Just under 14. So that's the general consensus between cosmologists and physicists and astrophysicists in the field. And so around that time, somewhere around 14 billion years ago, the universe was born, and this has been called the Big Bang.
Yep, and it gets weird already right at the start, right? The universe is born. What do we mean by that?
So it is a strange thing. So very little is known actually about what started the universe, and after that, it's quite well sort of agreed about the evolution of the universe. But as far as why
given it started, then the other stuff kind of follows quite nicely, and physicists can more or less figure out why things happen from that 0 point in time, but try and go backwards before that, and it's anyone's guess at this point.
Exactly, because backwards before that, there was no time, there was no space, so it's kind of a hard concept. But so at the Big Bang, for whatever reason, the universe began, and there are a few reasons out there, a few theories, like quantum fluctuation, which we would have to do its own video on, but it's about negative energy and borrowing energy debt to create something from nothing. I guess you'd have to look to Brian Cox or Brian Greene or Neil deGrasse Tyson could probably cover that quite well.
Yeah, there's some great stuff on YouTube about those events. Also, there's multiverse theory as well. Maybe there was something before the Big Bang.
True,
the
exactly.
Primordial pre-universe soup.
Yeah, so anything multiverse-wise could have been going on before our universe as we know it today began. But once that happened, for whatever reason,
we'll just call that zero.
Call that time zero. So that's when time as we know it started. And straight away there was an initial expansion period called inflationary theory, I believe, or inflationary cosmology.
Yeah, so inflation period. Which is what those things are.
Yeah, so that's when the universe, which has just been born, underwent a rapid expansion in size, which it hasn't really changed. It hasn't gotten much bigger since then, I don't think.
So I think most of the expansion in size, well, I don't know actually.
I don't know actually, but
that would be something I couldn't actually comment on, because there's, it's accelerating, isn't it, the expansion?
Yeah, that's true, and so the expansion's faster than the speed of light once you hit the light sphere, so you're right. But in any case, once the universe was born, it went through an expansion period where it grew really big really quickly, and that allowed for the formation of particles as we know them, once there was enough space to fit them in, essentially, and then once the first particles could form, physics sort of started. Is that fair, do you think?
Yeah, I think the space really involves the cooling of the whole system, right? So that right at the start, everything was so hot, it was just one giant mash of
subatomic
energy, and then that started to crystallize out into what we know as matter because of cooling, because of expansion.
Crystallize is a good way to put it, because it's just
heard
kind
that
of
term used in the context before. I'm not sure if I'm using it correctly, but it seems to make sense.
Yeah, so because there was no kind of laws or anything yet, possibly.
Yeah, so
and then
the
numbers
crystallized,
yes,
or at least the constants.
Yeah, so the physical constants got fixed. So these are things like the the speed of light, the strength of gravity, the electroweak force.
Yep.
And I think there's about 20 numbers, the constants of nature that were set at this time early in the universe, and then the way they've been set kind of allowed for us to exist billions of years later. So that's quite amazing. It's like it's the Goldilocks theory, I think, where all these numbers are just right where they need to be to allow for planets and stars and us to form.
Yeah, so there's been a lot of simulations with big computers recently about universe expansion and modeling different types of inflation, and there's different types. I can't remember what the names are, but there's at least 3, I think. I've seen something about that before. But yeah, they change one tiny little thing and you get a huge change in the result out the other end. So whether you get planets at all, or whether matter can never clump together enough to get planets.
Yeah, so slight changes to any of these numbers, you pretty much rule out humans evolving, I guess, to 6 or 7 decimal places if you change any of those numbers.
Yeah, so it's a fluke. We even got rocks.
Yeah, rocks were the hard part.
Yeah, maybe they were the hard part, right?
Yeah,
maybe
yeah.
everything comes from.
So
you've got rocks, we'll get all the other stuff now.
Yeah. We're pretty much the same. Yeah, if you got a rock, you got 99%.
We didn't even have rocks. We had, it was a fluke. We got stars, or star-forming regions to begin with.
Yeah, so we've got the Big Bang, the inflationary period, atoms and physics sort of form out of it, and then from the rules of physics, this allowed for stars to form and solar systems, and fusion started.
Yeah. Gas clumped together, it squashed itself so much because of gravity that fusion starts. You get stars. Stars are converting the hydrogen into helium, so you get more helium.
Some fusion.
I think most of the atoms in the early universe were hydrogen, and then probably a tiny bit of helium. I don't know if there was any helium spontaneously.
I think there was
stellar fusion, but
I think it was a small fraction helium and almost everything hydrogen, and then every other atom came from supernova and dying stars.
Yeah. So everything else has to come from the byproduct of stars.
Fusion and then supernova.
To get the even heavier things like gold and all of that comes from only supernova.
Yeah, which is Carl Sagan. We're all stardust.
Although that Kurtzgesagt video the other day was talking about neutron stars tunneling into giant balls of iron. That was over infinite time periods, so maybe that's why it hasn't happened yet.
We haven't seen
maybe
too
there's
much
a way to get heavy metals without
supernova.
Yeah.
Right. And then
wait a long time.
Yeah, that's a whole nother video. We might have to make one about neutron stars decaying into iron. And so we've got, so star formation, and then planet formation, and then as far as we can tell, this just kind of happened for like 10 billion years without much change, right?
Yeah, well, bigger and bigger things clump together. They think now that, the center of every galaxy is a huge black hole, which I guess was when stars supernova. You can get a black hole, more things collapse into it, the black hole gets bigger.
So then we've got galaxies around
even more mass,
Yeah, and then that sort of just went up until today, really, I suppose. Well, not until today, but until Earth formed.
Yeah, relatively moments ago.
Yeah, in cosmic timescales, yeah. So Earth, I think, is believed to be 4.5 to 5 billion years old. And then once Earth formed and cooled, I think life came around 500 million years after Earth cooled down. And then, so that's another thing. So we don't know what caused the universe to start, what caused the Big Bang, and we don't know what started life.
Yeah, we still don't know what sort of kick-started early bacteria, I guess, or something archaea. So we've found amino acids and things in space, so the building blocks of the Earth.
So physics to chemistry we're moving into now. The chemistry sort of allows this to happen, but the few theories of the start of life, there's an idea called panspermia, where some asteroid came to Earth and then that had some bacteria on it, and that's where we came from. But I don't really like that theory because it just removes the question on how life started away from Earth.
It just shifts the goalposts. It's not really solving anything. It's just like, well, it started somewhere else. Okay, then how did it start somewhere else then?
So then there's some other theories about, because some people think that life started as like a living single cell, but I've seen a theory where they were predicting that it started around a chemical reaction.
It started as RNA or something.
And there's a theory about RNA as well. It could be the same one, I'm not sure. But this one was just reinforcing a chemical reaction to keep happening. So in situations that protected that reaction and kept it happening, this kind of
so it was
started,
just like some reaction
it was like the Krebs cycle
that had a positive feedback cycle built into it.
Yeah. And then so more of that reaction happening, and then through natural selection it kind of got protected and then reinforced, and then this feedback happened. So that's an interesting potential way as well. So for whatever reason that the life started on Earth in the primordial soup, then what happened? Then you had single cell.
Yeah, so once you had your bacteria, or your early bacteria,
and this is moving from chemistry to biology now.
Yeah. That's when you had a bit more information processing. I guess once you had RNA and DNA.
Yeah. So
arguably RNA was first. I don't know. Can't remember the details on that one, but once you're there, then you're in the full swing of Darwinian selection and evolution as we understand it today.
Yeah, at least biological natural selection. I guess you could argue that there was some sort of natural selection on things before life, but as far as Darwin's natural selection, that's right.
Yeah,
and then so survival of the fittest, all that type stuff, and
so the bacteria branched out. We got a continued line of bacteria. We got the line of fungi. We got the line of plants.
So from single cell to multi-cell was quite an important step.
Prokaryote to eukaryote.
Exactly. So I think prokaryotes, which is single-celled bacteria type things, and archaea, they were around probably for 1 billion years by themselves, or something like that.
Around longer than everything else.
Yeah.
If you
maybe
do
longer
true
than
to
that.
scale, then they probably have the longest.
Yeah. So they were dominating the world for a long time, just single-cell things floating around in the ocean. And then cellular life came along, and then cells could specialize more, I suppose.
Yeah, I guess maybe some single cells figured out how to live together.
There would have been colonies first, sponges and...
Yeah, so those multi-single cellular, like a sponge.
Colony, yeah.
Colony type organism.
And then I suppose,
Is coral one of those?
Yeah, I think so, yeah. And then you can start to differentiate regions of your colony, which I guess is true.
To be more efficient.
Towards organs,
Yeah, so cellular... I mean, I guess cells had organelles before that as well.
That's true. It's kind of an abstraction on that.
Scaling it up.
Yeah. So you had organelles inside the single cells, and then you've got the single cells in colonies starting to organize themselves into some sort of proto-organ situation, leading to more complex things, like dinosaurs and things. When things moved out of the ocean, must have been a huge step.
So even for the scale of dinosaurs, I think I heard some fact the other day that the T-Rex is closer to us in time than it is to a
Stegosaurus.
Stegosaurus.
Or a Triceratops. Yeah, I think I've heard that one. Yeah, which is quite funny because you see them in pictures together.
Yeah,
fighting each other.
Yeah, that's right. It's funny, but the lifetime of, or the range of the period of Earth where dinosaurs were roaming the Earth, so to speak, so long compared to mammals so far.
Yeah, I don't remember the exact number, but I think it was tens to hundreds of millions of years dinosaurs were around. So how long humans are?
So I mean, looking at this chart in front of us here, it says earliest humans, and we're pretty much on the 0 line. Yeah. So the scale doesn't even show.
We don't even register on.
We don't even register it on the time scale.
Yeah.
That fits on the screen.
And then, so that's the step from biology to consciousness. So there's varying degrees of consciousness. I think you could very successfully argue levels of consciousness. So, dolphins and chimpanzees can wipe paint off their own head when they're looking in a mirror because they recognize themselves. So that's
so they recognise that it's something stuck on their own head, not themselves.
Yeah,
They've seen their own reflections before and recognise themselves as well.
Yeah, so that's a level of consciousness as well, and then so that's another step. So we've gone from physics to chemistry to biology to consciousness.
But can a dolphin, collapse a wave function by thinking about it from the other side of the world?
Yeah, well, Dean Radin would probably say yes.
So someone commented on that and said, we might have to talk about that in another video, but it'd be a good test of consciousness.
Yeah, so that would be a good test of consciousness.
So consciousness has been argued that it can affect quantum reality. So if it can, then maybe the converse would be useful. You could say, if you can affect quantum reality, then you're conscious.
Yeah, that would be a really good way to define consciousness, is your ability to...
Because then it would be a sliding scale as well. It wouldn't be on or off. It would be, how far can you make the peaks get towards the troughs and the...
Exactly, yeah.
It would be an experiment.
Would be a continuum as well, yeah. So that's where from into consciousness now, and then do you think there's a next step? Like digital superintelligence or something that we might enter into?
Yeah, I see that just as an evolution of intelligent life in general. I think it was probably just a natural thing to happen. Once you get good at building things, you rebuild yourself further and further, right?
I like that idea of you can sort of reverse engineer yourself, but also you don't have to understand how you work to be able to do that. Like a computer coder can write a program that plays chess even though the programmer doesn't really know how to play chess.
As long as, because he can test the outcomes to say, yes, that's a good move, or that's not a good move. Or not even that, he can test the outcomes to say, yes, you won, or yes, you lost.
As long as you've got the feedback,
yeah. As long as you have, a testable way to iterate towards your solution, then you'll get there.
Yeah. So that brings us all the way up to today and a little bit past. So hopefully you enjoyed a little tour of the universe, and we'll be back with some other topic next.
Yep.